Welcome to this explainer. Today, we're tackling something that is absolutely fundamental to your modern data center, and that's deploying your SuperCloud Composer. You can think of SCC as the high-tech control tower for your AI infrastructure. But, well, here's the catch. Even the absolute best control tower in the world is going to fail if it doesn't have a flawless blueprint to start with. So today, we're going to walk step by step through sizing, securing, and deploying your environment, really making sure you avoid those super costly surprises down the road.
Okay, let's dive into this blueprint. We're going to start with the AI infrastructure shift, then cover sizing your SCC environment, define some strict network addressing rules, look at deployment and form factors, and finally, we'll wrap up by configuring alerts and access.
Section 1, the AI infrastructure shift.
So, to really understand how to deploy SCC effectively, we first have to establish why the data center has fundamentally changed in the first place. Think about traditional air-cooled environments. Monitoring was pretty straightforward, right? You focused on standard systems, some basic network switches. It was a pretty low volume of telemetry. But a modern AI workload, wow, it completely changes the game. We're talking about AI infrastructure that demands high-volume GPU telemetry, massive network capacity, and incredibly complex liquid cooling data. You aren't just monitoring a single server anymore. You're ingesting this massive, constant stream of metrics. Your control tower literally has to be built for this heavy load.
Section 2, sizing your SCC environment.
Because of that massive data load we just talked about, sizing your SSC environment correctly from day one is absolutely crucial to prevent structural failures later on. Let's talk scale for a second. In a scenario where you have 512 system nodes spread out across 132 racks, you'll need your 3 master nodes and a minimum of 2 to 3 worker nodes. But watch what happens as we scale up. By the time we hit a massive 2048 node AI deployment across 528 racks, your master node count stays at 3, which is pretty standard, but your recommended worker nodes, they drastically jump to a minimum of 8 to 12. As the number and the types of managed devices increase, especially with those heavily monitored GPUs, your worker nodes have to scale aggressively just to process all that incoming data. Now, what's really interesting about this is that your physical rack layout can actually dictate your SCC sizing. It's like a giant puzzle. You might have the exact same number of system nodes, but if you choose to spread them out sparsely across, say, several hundred racks, rather than fully populating just a few racks, you are dramatically increasing the number of power distribution units and cooling distribution units that need monitoring. A wider physical footprint literally means a heavier telemetry load on your SCC, even if your actual server count hasn't changed one bit. So, because of all these crazy variables, from GPU volume to your rack design to your polling frequency, initial sizing is really just your baseline guidance. As the architect here, you absolutely must monitor the actual resource consumption once this deployment goes live. Keep a really close eye on CPU usage, memory, disk I/O, and event ingestion rates during that early production phase. Actually, 2 deployments with the exact same node counts can have wildly different resource needs. Reviewing this live is for sure the best way to prevent both a sluggish, undersized environment and a totally wasteful, oversized one.
Section 3, SCC network addressing rules.
Okay, let's get into the plumbing of your data center, because this is where those really frustrating, hard-to-diagnose errors usually pop up. First up, we have to clearly define the SCC appliance management network. Think of this as your front door. It's the single, default SCC network used for external management access and routing. And importantly, it's the only one that requires customer visibility on your wider network. Everything else, that's strictly behind the scenes and heavily isolated. We're talking about the Docker Bridge network in the Harbor VM, sitting at 172.17.0.1, the Kubernetes cluster subnet handling pod-to-pod communication at 10.42.0.0, and the Kubernetes service subnet for virtual IPs at 10.43.0.0. All of these are entirely internal to the SCC platform. They are non-routable, non-advertised, and they absolutely must not be exposed outside of the SCC control boundary. They have zero dependency on your tenant or application networks. I am going to wave a massive red flag right here because this is vital. You must verify your network addresses. All of those internal SCC IP ranges we just went over, like that 10.42 subnet, they're fully configurable default values. If these defaults overlap with your organization's existing or even future IP addressing, you have a huge problem on your hands. Overlapping CIDRs can cause internal platform traffic to be inadvertently routed completely outside the SCC host boundary. This will immediately impact your routing behavior and just completely break platform operations.
If there is a conflict, you absolutely must customize these internal ranges before you deploy. No exceptions.
Section 4. Deployment and form factors.
Right, so now that our sizing is calculated and our boundaries are firmly drawn, we can transition to the actual deployment itself to determine the physical and virtual shape of your control tower. Before a single system is commissioned, you've got to nail down some basic but highly vital prerequisites. Are you deploying SCC on a physical machine or as a virtual machine? If it's a VM, exactly what Linux version and hypervisor are you using, like Red Hat 9.4 or KVM? You also need to document the exact physical location. We're talking country, city, data center, right down to the specific rack. And finally, is this an online installation with internet access, or is it a highly secure, completely air-gapped installation? These parameters dictate exactly how your installation sequence will be executed.
And this brilliantly illustrates a golden rule of SEC architecture. If you're just running a lab, a minimum setup, or a proof of concept, you can absolutely get away with a single master node without high availability. But the very second you move into any production environment, I don't care if it's a tiny small site or a massive enterprise deployment, you strictly require 3 master nodes. High availability is not an optional add-on in production. It is the fundamental structural integrity of your control tower. 3 masters, always.
Section 5. Configuring alerts and access.
Finally, we reach the operational layer. Your infrastructure is sized, it's deployed, and now? Now SCC needs to talk to the outside world so it can actually warn you of issues and authenticate its users. You'll handle this through the post-discovery customer information spreadsheet. You'll need to configure your SMTP relays so SCC can fire off emails. This means specifying the fully qualified domain name or IP of your SMTP host, picking your port like 25, 465, or 587, and setting up the encryption method. Crucially, you've got to explicitly permit specific SCC source IP addresses, for example, 10.1.50.111, to connect to that SMTP relay. If you forget this step, your alerts are just going to hit a firewall and vanish into the void.
To make sure the handoff goes smoothly, you really want to get all this information prepped in one session. Beyond just the SMTP details, you also need to confirm if your relay can temporarily send commissioning alerts out to an external Supermicro email for testing, or if you have to provide an internal fallback for that. At the same time, if you're using Active Directory for user access, you need to have your AD domain, the controller IP, and those specific AD bind accounts and groups totally ready to map to your SCFUC roles.
And listen, you definitely don't want every single notification firing at once to everyone. That's a nightmare. You must define your alert policies up front. You need to assign specific email recipients for warning and critical alerts, categorized by things like BMC or server operations, power management, and your cooling devices. Structuring this carefully is what prevents notification fatigue. It ensures that a critical liquid cooling alert goes directly to the facilities engineer instantly, rather than just getting buried in some generic IT inbox.
Okay, I need you to hear this one loud and clear. Security red flag here, folks. The source documentation is incredibly explicit about this. Do not, under any circumstances, enter passwords for your SMTP authentication or your Active Directory bind accounts into this spreadsheet or send them over standard email. Seriously, don't do it. Passwords absolutely must be provided separately using your organization's approved secure communication methods. Failing to follow this compromises your entire management network before it even has a chance to go live. Well, we've covered a ton of ground today, haven't we? From the heavy demands of AI telemetry totally altering our sizing guidelines, to the strict isolation of internal Kubernetes networks, all the way down to securing our SMTP alerting. So I want to leave you with this final question to chew on as you look at your own blueprints. Is your infrastructure genuinely validated, accurately sized for the realities of your specific rack layout, and safely addressed to avoid catastrophic routing loops? Take the time to review your plans against this blueprint today, because in the fast-paced world of AI infrastructure, a flawless deployment is literally the only deployment you can afford. Thanks for joining.